Hello. Nice to see you guys. I see y'all for another week of SimPEG. Oh, we got Devin joining us too in here. Obviously, you can see we got some people in the GIF room. We've got a new face joining us for today.
Hello.
Introducing yourself, tell me a little.
Sure, yeah, I can give a quick introduction. My name is Craig Christensen. I am a Canadian guy living in Norway. I work with a company called Emerald Geomodeling. We're doing airborne EM, specializing in geotechnical applications. And since I'm on a long homecoming tour, visiting friends and family in Canada, I thought I'd pop in to say hello to some of the guys working on in GIF and on SimPEG. We're looking at ways of streamlining our whole workflow to make inversion simpler and easier, because what we use today, what is in, is kind of hard to interface with. So I'm going to be a fly on the wall today, just listening in, seeing what kind of stuff you're working on in SimPEG, and hopefully getting a better sense of what you guys are working on. So that's it about me.
Glad to have you here. We go around the table for everyone also to present what they're doing in SimPEG. I think that's it's been a while since we've done that kind of thing. Yeah, sure. My name's Joe. Nice to meet you.
Hello again.
Kind of in charge of making sure everything comes into SimPEG. It's been thoroughly reviewed and works properly. Kind of like the last goalpost to get through.
You're the gatekeeper.
But no, other than that, I just focusing on developing the open source code mostly, and doing research with it. Yeah, so Thibault. Hi, so I'm Thibault. I did my PhD at UBC and now a postdoc until the end of the month. So I'm mostly focused in SimPEG in developing the first multi-physics inversion. Now we have more coming in with post-gradient, etc., from other group in Houston, so that's amazing. But that's been my main contribution to the package, and yeah, I'm actually moving back to industry starting in January. So
Exciting.
Don't know how much. Like I will still be using SimPEG and hopefully still contributing, but there might be a transition.
And then I'm Devin. I have various jobs with UBC GIF, but a lot of what I do for SimPEG is, I guess I'm the guy responsible for most of the tutorials and working on getting the API set up and that kind of stuff. So less geared towards research, but more about kind of making sure people understand the functionality and trying to make it more accessible.
Lovely.
And writing all of the documentation, which is amazing.
Wow. No small task.
Yeah, self-confidence boost.
Excellent. I'm Lindsay, assistant prof here with UBC GIF. Do lots with geophysics, interested also in machine learning applications with geophysical data.
Lovely.
And to the online crew here, John, how do you start?
I'll go first. I'm John. I work mostly in industry with DS Geophysical and DS Airborne. I'm mostly working on frequency domain stuff, MT, and DC resistivity, and trying to make inversions go faster. So parallelizing inversion best we can.
Cool. Nice to meet you.
John. Sorry. John, is that so? DS Airborne is a separate company now? Is that kind of the idea, or
It is,
kind of
yeah.
curious?
Yeah, they're
Oh,
kind of separating
interesting.
Airborne, and I don't know what they're doing actually. So to be
I
honest,
see. So you guys are branching off, and
yeah, we got a spot, we got an airplane hangar and stuff now, so it's getting more.
Yeah, I'm sorry. I did my PhD with Doug and Lindsay together, and yeah, these days I'm mostly working on airborne electromagnetics and applying that into California and groundwater issues. So yeah, I think I'm sort of the major developer of our 1D EM code, which is sort of the major tool that we're using for inverting the airborne EM data. Yeah, so it's see you here.
Cool.
And I'm Dom.
Can I just step in just for, oh, sorry, Dom, I didn't see
No.
you. Go ahead. Go ahead.
Go ahead, Master, first.
Yeah, I just wanted to welcome you, Craig. Really nice having you. I'm sorry I wasn't able to get in this morning, but I'm looking really forward to hearing what you're doing. And yeah, these days geotechnical work is it's pretty front and center with all of these floods that are happening here. So really interested. So yeah, look forward to hearing about what you're doing.
Likewise, nice to finally meet you.
And I'm Dom. I also did my PhD with all this crew, and also in the industry, Mira Geoscience, and then kind of work in parallel with John right now for optimizing the EM codes and some potential field stuff. That's me.
Nice to meet you.
Okay. Yeah, so it's announcements. Lindsay, I see for that we got a newsletter coming out soon.
Yeah, so if you don't mind adding any items, published papers, talks coming up, Thibaut, we should put a plug in there for your M&R.
Yes.
And then I think we need to decide, are we going ahead with a poster session-y thing, or are we just gonna let that pass for December?
Did anyone reach out saying they had stuff available?
No, but we haven't really made a concerted effort to
Okay.
make this happen, so.
Yeah, my poster is the one that's in Instantiation
Yeah.
right now.
I don't have particularly strong opinions. There's like enough going on in December. I'd be happy enough to like announce Thibaut's seminar and kind of have that be what we're pointing folks to. But if anyone's got a desire to share what they've been up to, we can make this happen. So I don't know. Does anybody really want to have a SimPEG poster session?
I'm okay if we pass on it, and except if anyone has a very strong opinion and really want to present something, which would be amazing, but I just think it's okay if we just pass. I think that's fine.
Okay, that was easy. So yeah, so then just any other like development items you'd like included in the newsletter, papers published, things you want to advertise to the community, just drop them in that link there. That's it.
Okay. I don't have any other announcements or anything, so move on to quick reports as we're going through here. Since last week, just a few little small updates to the cross-grading stuff, checking this stuff around. As part of that, I'm also going through and working on getting rid of all of the deprecated items like we talked about. They are now throwing errors, pointing people to the right thing, so force people to change. It's taking a while because a lot of the tests need to be updated. That we're using old calling conventions, so it's the long process of going through all the test folders to make sure that it's using the updated thing. Whereas before it was not, because we just left them as they were, so they tested both things at the same time. That's where I'm at, and then going through that on SimPEG related items.
Yeah, so yeah, I took a stab at making a couple of those tests. It seemed like so this was for the electric source, or for the line current source in SimPEG doing time domain EM. And it seemed like if we just did a whole space and put an electric dipole, the electric field produced by this seemed to work pretty well, but the magnetic field being produced by that wasn't accurate. So anyway,
Were you looking at magnetic or DBDT?
both.
Both did not look right.
Yeah. So I think there's still some questions I have in there, but there's a whole host of things that you could run and play around with it. We just need to implement it and do some more testing. But at least it's all set up so that you don't have to start from scratch.
Okay. Do you have any plots or things like that that would be useful to chat through either today or just through for the pull request to sort through why DBDT isn't looking?
Yeah, we could take a few minutes and just kind of sort through after the meeting or whenever you have time. But I already put it in the tests for SimPEG,
Yeah.
And there is a plot it function.
Okay, cool.
So you'd be able to just run it and then see the comparison between the analytic and the numerical solution. So yeah, it's set up pretty good to troubleshoot.
All right, excellent.
That's about it.
Yeah, I mean, also with Devin, we're going through stuff. I know we talked a while ago about the properties changeover. Switching out from that, talking about just generally what it would look like. We talked about looking at a few different things, one being one way, we're talking about the initialization of classes. We were looking at just the potential field modules, so maybe the gravity simulation, to kind of see how many items it would take, like how many defaults there are if we wanted to explicitly list everything every time. I can share my screen here. You guys can see what it would, like the amount of options right now that are there that would be required. Sorry. So the easiest way to look at this is just to look at the documentation of that gravity. So this is the gravity simulation kernel, right? So these would all have to be outlined in the init script if we want init script, if we wanted all of them to be available every time, like to have it look like be the most descriptive thing, as opposed to so those are all of them. We look at, so the options were something like that, where we just have them all. Great. The second option was here would be something like super. This one we would do something like
Well, in the first one, you wanted to pop keyword arguments that weren't in the parent class, right? I thought that's what you were doing.
no, for this one, for this one, yeah, you would pop it off. So. All right, so this way is the least intuitive way of looking at it, right? We don't see anything in the initialization keywords here. This option, this one, we at least see the new things that are defined in each class. And then obviously the last option that we were just talking about is just to list them all for every one of them. So this would, right, it would list everything there for everything. This gets very cumbersome, right? Yeah. It gets, like, it is most descriptive, but if you look at the amount of like required properties that we are setting in each of these simulations, it gets kind of out of hand. And it gets kind of hard to extend, right? Because every time you extend it, you have to like have it all in. And let's say we add a new option on a base class somewhere, you have to update everything that like uses that base class.
One thing I think I've seen, I don't know if Matplotlib does this or others, but I think the required properties we still potentially want to list, like have explicitly in each, if there aren't like straightforward defaults.
Yeah, what we can do,
Like the fact that we always require the mesh explicitly to instantiate a class, I think is a good thing.
yes.
Yeah, I was gonna propose the same thing. Like when I look at the SimPEG code and you look at, okay, that's the thing, but sometimes like you have to really go up the tree to see what's the actual argument that you need to put in. And like I was gonna say, like, I understand it's like kind of like a in between, it's not required, but like in the middle way, like you would be, like, you list the new things, but you also always list the ones that are always required, and that's make it very easy to read the code.
Yeah, that would be best described in like in the doc strings, right?
Well, something else Joe brought up was the fact that upon instantiation, you should be able to use that use that object right away. So say time domain EM, you don't have to set the time steps when you instantiate it, but that is something that's required in order to actually use the simulation. So kind of an idea of kind of forcing it to be a valid object upon instantiation.
This would be kind of like the default way to do this kind of script here, to go just be very explicit that they're passed to that class and linked to them. Obviously, we can list as many of them as we want, right? In the parameters, but I think this method is going to be the best way, the most extensible, easiest to implement kind of way moving forward.
I agree. Like the top one is really like if you're a developer, then like it makes things really hard to read, and the last one is just cumbersome to go, like, as you said.
Yeah.
One other suggestion here, I know I brought this up last time, but it still does seem to me that starting this in GeoAnna actually seems like a good idea, because we have to do this there anyways at some point, and it is a simpler code base. And so that would be a suggestion. It's a question of order of operations, but I do think it would be easiest.
It would be like that class is, there's not many, like, we don't have to deal with like any sort of like listeners to objects. We don't have to deal with observers, things like that. So it's very, very simple validation on that needs to be written. So that could probably be a good place to start. Just get rid of it from there.
Yeah. So just as a matter of context, maybe for you, like GeoAnna, it's a separate package from SimPEG, but that's where we store analytic solutions. So that's a very useful package to check that our simulation code work very well, etc. So, but it's also a very simpler one compared to SimPEG, but it has a lot of similarity in the architecture. So that for that type of chart, it's also that's why we want to start with that.
Understood. Thanks.
Yeah, that could work. I guess I'm wondering, what is the level of urgency for getting the SimPEG API online? Because that's sort of where this whole thing started. And then we realized in order to do that, we had to exercise properties. So then we started working on that. And then we want to go and say, okay, well, let's test things out on GeoAnna. So now it's like we're adding steps earlier, which are taking us further away from our initial goal. I mean, if we think that this is ultimately the best way to proceed, then I'm all for it, but it's just something to keep in mind.
I think it's good to start with GeoAnna because also like since we're still making decisions on the go, and it's much easier to try them out on GeoAnna first, and then once we reach something that we're happy with, to apply it with SimPEG. That if we iteratively and dynamically make decisions along the way on SimPEG, it's just such a bigger package that's gonna take forever. That's my vision of it.
Yeah, that's a good point. So I mean, I could put in the work to get this thing correct for GeoAnna, and then we've come to a consensus. We stick to it, and then just start working together to implement it. So I'm okay with that.
That'd be awesome. Yeah, because I think they do eventually both need to be done because we need to get properties out of the SimPEG dependencies. So, and SimPEG depends on GeoAnna, so it needs to get done at some point.
Yeah.
So that'd be awesome.
Okay, cool. Okay.
Is there there's a website for GeoAnna
I
as well?
think it's quite out of date. So it was on Read the Docs, but I don't think it's actually even properly deploying.
No.
So having that on GitHub pages would be good and should hopefully be pretty straightforward.
I know the docs build, they're tested.
Yeah.
It's tested at the docs build, so.
Right. So we
Okay.
can build them. We just don't show them to anyone.
Yeah.
So-
But it sounds like there's a definite need to get the GeoAnna package up to the same quality of discretize. And get that stuff to build properly, get it fully documented, and then
We
happy
can,
with that, we'll move over to SimPEG.
So then we just need to get a GeoAnna.SimPEG.xyz.
Yeah, I can create that on Google, so just let me know when GitHub pages is up and we'll connect the wires.
Okay. So that's me and Devin. John, I see you up to that.
Yeah, just been playing around with a little bit of part of the SimPEG side of things was just doing the worker, just a custom worker to sit on the nodes that do all the heavy lifting. Now I integrated PyDeso. I found that, yeah, if you got any old branches that you're still using PyMKL through PyMat Solver, something happened on Anaconda and they updated some of their back end, and it's now the MKL file is libmkl_rt.1.so. But yeah, by moving to PyDeso, you use the header in there, it looks like, Joe. So it just, yeah, that one works. But yeah, if you're trying to do the old PyMat solver at all, watch out for that.
Yeah, I changed it. That might have been it, Don. We were talking about the MTs. I changed the name so it would find it. So I might be using the old PyMKL library instead of the new PyMK or the MKL on my computer. So the file
Yeah, just
name,
switch to PyDeso and then you won't have that problem.
Yeah, PyDeso just, yeah, it runs it well. So I've incorporated that now. And then, yeah, I have it writing the factorizations, and now the custom workers will find, or so if they have to run the JVec or JTVec loops, they'll find that factorization and use it. So you get like a 2x speed up in the loops there as well by writing the factorization to dist. But yeah, that's all I've been up to.
Lindsay.
Yeah, one more quick item. Got an email yesterday from someone at Mira about using the SimPEG logo in Geoscience Analyst to indicate sort of UI for when SimPEG is being connected, which I think is a good thing. It's good to sort of illustrate, you know, where SimPEG is used and have that branding with it. I think what that does bring up is that we should have just a bit of guidance on where the SimPEG logo can be used, how it should be used, all of that sort of stuff actually documented. And so the Jupyter, Rowan pointed out the Jupyter docs, governance docs, have a very comprehensive guide. And so we can use that as a bit of a starting point and kind of tailor it to our community.
That's yeah, I was going to come with that question actually. I've been putting SimPEG logos on any inversion session that we have and stuff, or when we do release Caravelle, it's all going to be logoed for SimPEG and everything like that.
That's awesome.
We need like a powered by SimPEG logo.
We do have that badge. We do have
Yeah.
a Powered by SimPEG badge, but I think like it's great to have the logo used when SimPEG is used. And so yeah, just having some guidance to sort of encourage folks to do that, I think would be good.
Soggy.
I did a little bit of work. I ended up updating that EM1D branch, so I made a pull request to main. Seems like there are some errors in the existing main branch. So I guess, although I think I have some problems. Actually, I got a quick question to Joe, because there was an error for the source class, and then previously we used the SRC list, and then now it's changed it to source list, and that kind of triggered the errors. Is that like is that expected?
It shouldn't have triggered any errors. Like it should have triggered some warnings for you.
Yeah, I don't know why, but it's that, yeah, that was the error. So I had to change that SRC list to source list to pass the So I thought like that's related to some sort of updates that we've made. But, and the other thing was that the version of GeoAnna, I think for a certain system, it actually used a lower version. So that kind of sometimes triggers the error in the Travis, like that Azure test. So it would be nice. Is there any like a reason why that certain kind of for certain system that GeoAnna uses a lower version?
I don't know. I think we just need to we need to pin a specific version requirement when we're installing it.
Yeah, that's actually that's what I did. Okay, so yeah, as long as that's fine. Okay, that sounds good. Yeah, so if either Joe or Dev if you can take a kind of look, because I think most of like all the passes related to that part of addition is passing. So yeah, if any of you can take a look, that would be great, and if you can merge that within this year would be perfect.
Do we have the electric dipole solution coded up in that, or are we just doing inductive sources for now?
It's only for inductive source. There's no electric dipole.
Okay, that'll be a separate project when we're done the 8 million projects we're all working on.
Yeah, I think for generalizing kind of that code, I would basically use the Dieter's code and just find a difference for sensitivity. Yeah, unless like somebody's interested deriving all this propagation.
Kind of interested in it too, at least as a self-contained example, because I've been doing that SimPEG code validations project. And so with Lindsay adding galvanic sources to the EM simulations, want to compare 1D analytic and like a 3D octree. Yeah, that would be useful for that project, but I'm not sure if anyone else has something that's very tailored to a particular research thing that they're doing.
Well, with PyMod, you should be able to do that. I think, Soggy, your suggestion about sensitivities is if we want to do the inversion.
Yes.
Yeah.
Yes. For the for modeling, I think you can just use PyMod. It's already developed.
Yeah, that's true, and that fits in with the framework of this project or this website. That would be fine.
That's it on my end.
Sean, how are you doing?
So in the last weekend, I tested the cross gradient method. I use two different synthetic model. One is the 3 simple blocks, and another one is the more complicated. It's a horseshoe shaped synthetic models I used in my paper. So they all works well. So and another thing is a question for you guys. So how do I implement objective functions consist of the 3 parts? One, data misfit terms, and second is regularization terms, and the third part is another terms. So just wondering, is any easiest way or the fast way to implement such objective functions? So based on my understanding, I needed to generate a new file. This file contains the first and the second order derivative of the phi t, and then I just need a reg plus the regularization, taking of regularization and the phi t. Is my understanding right?
So you want to know how you create a new like regularization? So all our regularizations extend like the objective function class, right?
Yes.
So you can just add them together.
Okay.
And then your class will need a deriv and a deriv2 method inside, right? And then that way when each of the components are called for the first and second deriv, then they have a function to pull from, basically.
I see. Yeah. Thank you.
Yeah.
Good. Anyone else? Thibaut, Don, Doug?
Well, shout out to you, Joe, Sag, and Dev for helping out with debugging MT. So it's getting better results. Turns out that we cannot have data right on the node. It's a bad idea. Don't do node. And then, yeah, draping is very important for MT, as you were saying, John. So lesson learned.
Yeah, speaking of that, because Joe, I did not realize that in Octree code for the edge interpolation, it's basically the nearest neighbor. So this is something that potentially, is that right? Like that's what we've recognized.
That's what it's been. So it's what we can do, and what I've been meaning to get to at some point is update Octree or interpolation to at least do like trilinear when the adjacent cells are all the same level. The interpolation gets tricky when there's transitions between levels. And you're trying to interpolate through them. That's the only, that part is actually really rough. So, but otherwise, like if it's just all the same level, we can probably update that to make sure and do like an interpolation more like a tensor mesh that way. But either way, right now, what the edge-based interpolation does is so let's say you're interpolating from the X edges at an arbitrary point. It looks to find the cell that point is in, and then it does a bilinear interpolation off of the other, like all 4 of those edges in a 3D cell.
Right.
So it only uses the edges in the cell that it's in. But it does do a bilinear interpolation. So all 4 of the X edges, right, are at the 4 corners of the cube, or 4 of the edges. Like they're all like this. So 1, 2, 3, 4. Within that cell, it does a bilinear interpolation for those components.
But if you're on the face, then it's 2, and if you're on the node or right on the edge on a single one, right?
Yeah, I mean, if you're right on the edge, then it's going to look at just that edge.
Exactly. That's why I was looking like a nearest neighbor. So it's because I was right on the node, right? So it was grabbing only that edge.
Oh, I see.
Then it was like a flip a coin. Which of the cell was it? The air cell or was it the ground cell? And sometimes it would pick the air cell because I was right on it.
Right.
So basically, you don't want to be on the node ever because that's like 50-50 chances that you're going to be on the wrong side.
Yes. So yeah, or again, for the example, like with the X nodes or X edges, right? It does that linear interpolation between them, but then along that tangential component, along the X direction, it's just constant. So that's why it's nearest neighbor in just one direction, basically. And a similar sort of thing happens with the faces. So with the faces, it's nearest, right? It interpolates linearly along the normal of the faces.
Okay. So what's your fix then?
Well, first of all, make sure that I move all my data points out of the node if I'm right on a node. I mean, in real cases, in real life scenarios, that's probably never going to happen. But for the synthetic case, it would, right? So you need to have a check that you're not on a node. And second, you need to be draped onto the active cells. You cannot have data points that's in the air because the field is discontinuous. So you need to have all your points draped on, basically. Those are the 2 checks that need to do under the hood. And also the 1D, it seems like the 1D values that we use quite important, right? That's kind of like follow Devin's lead on this and kind of have to put a connectivity that makes sense for the 1D boundary condition. I was not being careful enough, and yeah.
Yeah, it's quite fickle.
So getting closer, it's inverting.
That was impedance, right, Dom, that you were doing?
Yeah, impedances, yeah. Have you've done a permittivity phase, John?
Yeah, that one seems to be a lot,
stable.
a little bit more stable. Yeah. Depending where you are, the XX and the YY because it's got a possible division by 0, That can things a little, like if you're hovering around there, your signal is going to be really low. So you're gonna have to assign your weights really well, or else it kind of blows things up.
Yeah, that's what I was going to ask the group. So the whole like bottom, top bottom division that's happening in the impedance calculation. So we're not protecting against those crazy small E fields, eh? Like we're just assuming that H is gonna decrease as well.
Not sure that I'm following.
Well, I mean, we're doing a division, right? Anytime you have a division, you have a risk that you're going to have a near machine error, a zero division, and then your field's going to blow up. Your impedance value is going to blow up, right?
I can take a look today, and I think I can answer that question for you, Don. I would assume that there is a stabilization constant.
No, there aren't. No. It's multiplication, subtraction, and then division. there are no epsilons in there. Oh, you mean the E3D code?
Yeah. For E3DMT, right?
Gotcha.
Assume that there's a possibility for that, and then an important part of inverting that entire tensor is that when you have your on diagonal components, your uncertainties really are driven by a floor as opposed to a percent, like a frequency dependent floor.
Okay, but that's more like a user. Yeah, I'm talking more about like internally when we're computing the data, right? Like in the simulation. We should probably be protecting against the division by zero.
What cases would result in a magnetic field 0? That's what would happen, right? That's where the
Like, because in the denominator,
have really strong 3D effects. I'd have to look at that. I have a feeling it's probably pretty uncommon.
Yeah, I don't really see the case because you're not just inverting the single value, you're inverting the matrix. So as long as the determinant of the matrix is not 0. So, but I think that would not happen because once you got an orthogonal component, there shouldn't be like a 0 determinant of that matrix, I guess. So I think it shouldn't be.
okay.
It shouldn't happen in SimPEG when you're simulating.
Okay.
Joe and I were running a little few, like the unit tests there, and yeah, we are finding if you move the model, you could have it fail. If you just like position the mesh a little differently, yeah, it would fail. But again, it was if it lined it up that it wasn't that perfect scenario, I guess. It kind of happens, but I agree with Dom. There should probably be a little bit of protection just in case, because it seems like it is a possibility.
Okay.
Physically, though, it doesn't necessarily. Well, I don't know when you might have it, but if it was just like lowest frequency, basically DC effects, then whether or not you have a conductor or a resistor should just increase or decrease the electric field, but it shouldn't have a 0 crossing.
Yeah, I don't know about the physics. You guys know more about this. You're probably right, but just numerically, when I look at this, it makes me cringe to do a division without protection.
I'll take a look and see if I can find you an answer for that. But yeah, maybe it does happen. I don't know. We'll see what Roman did.
That actually is crazy. It's like 1D, but I mean, in 1D it just goes to 0. Like the XX, YY.
Well, in 1D, you wouldn't have a magnetic field along that polarization. So HX divided by EX is going to be 0 because you don't have any. It's only when you have 3D effects that you would actually get a non-zero H field in that direction.
Just the fact that you and I, Devin, ran exactly the same code. Technically same versions, and we're getting different spurious data points. Makes me think there's some instabilities somewhere. Obviously, there was like the whole node issue, but yeah, I don't know.
There's that, and there was the fact that I hacked my MKL so that PyMat solver would find the MKL library instead of using PyDeso. So I did some hacky thing on my computer to get that to work. I need to upgrade to the latest solver that we're implementing in SimPEG. So that one's on me, but there's definitely other stuff.
Yeah, I tried both installation and the solution was the same. So that's not it. Yeah. I tried the CG solve also, right? Just as a test, because I wasn't sure if it was Pardiso or something else. And man, I don't know if you guys have done iterative solvers on this, but not so stable, eh? You need to solve a lot, and even then, the simulations are not very consistent. So I will stick to Pardiso till further notice. All right, that's it for me.
John, I've got a question. So you said you inverted both impedances and also amplitude and phase. Did you notice like a substantial difference in the amount of time that was taken on one versus the other?
You know, nothing substantial, no. Actually.
Okay, it's interesting. Yeah, because I remember in previous years when we did this, there was actually a very substantial change in the amount of time, because you've got that extra mapping that's in. Anyway, that was one question. The other was when you're testing, do you have an example for how the system works if the phase actually goes out of quadrant?
That I don't, but that is something that I've been wanting to do. But yeah, not currently.
Do you have a data set that illustrates that?
I think that's kind of what I'm still waiting on. If I go back to that, we do have something around, but I don't know if Hugo got it to me or my MT guy, but we should have one, yes.
Oh, okay, because that would be really interesting. Not only from a numerical point of view, because now you have to worry about zeros in phase, but also yeah, just actually from a scientific modeling viewpoint, because many years ago when we're acquiring empty data through the Nelson batholith, then there was some questions about the phase, which for a number of stations was very compatible between stations, but it was just blasting out of phase. And then the question is, what's causing that? Are these just currents that are kind of sweeping in from the mantle or whatever, which then brings us back to the boundary conditions. And it seems to me that if we're testing the MT problem, it would be really nice to get high quality data that really shows that consistent out of quadrant behavior for the phase, and just see how the programs go and see if there's anything interesting scientifically to be learned from that.
Nice. Yeah, the data sets right now have just been 2D, so we just haven't really had anything to test it out with on SimPEG yet. And also I need to get that data set, but there is certainly some data floating around. I'll have to get onto it, but I'll try to serve that up for you.
Okay, thank you.
John, if you're inverting for what is it, the resistivity in phase, do you sort of have like a row XX and a row YY? Okay.
Yeah, it's all four. Yeah, or both diagonals.
So then row XX and row YY can go negative, I guess.
That's true. It should, or it could, sorry.
There's only an apparent resistivity.
Yeah, but
I guess it just goes back to Doug's question about which inversion would be quicker. And if you're doing resistivity in phase, but you only had values based off the off-diagonal components, it would probably be faster compared to the XX, XY, YX, and YY for impedances, because you have less data to fit.
Yeah, that's completely true. That's what we did on our last project there. They just wanted the off diagonal, and yeah, it was really quick. The dash just rocked. It was awesome.
Have you managed to test spatially, John? Your MP? I tried and it fails miserably. But
oh really? Yeah, I haven't found the time to get onto that. But yeah, it's failing really bad.
No, but I mean, it runs. Just the simulations are pretty crummy. You can kind of see a lot of. I think it will need to pad out a lot each of the tiles, and yeah, I'm not sure how much savings we're going to be able to make out of this. But
ooh, that's a good call.
I tried to tile by lines because I have like 8 lines, and then it was like, oh, it will save me a lot of computations. But then the model come out and like, oof, it looks rough.
Oh.
Yeah. Anyway, I was wondering if you tried.
No, I haven't got there yet, but yeah, maybe more padding, or hopefully we can try getting the boundary conditions in there. That we kind of.
Yeah.
I remember I was doing some other tests, like trying to, it was a simple tile version of the FT, like the forward modeling seemed to work really well. And I remember trying to invert it, like using the same kind of thing. It was really tough to actually get it to invert properly.
Yeah, I think we'll need to overlap quite a bit for MT.
The way I think the way that I was trying to do it was I had one mesh that worked very well. And I just moved that mesh around for each different station. And I didn't bother about trying to overlap. I just did the whole volume averaging, like the volume averaging operation between them. So. Okay. Mike, I see you came in here at the end. Got anything to share?
Not too much, no, just kind of plugging away at stuff and trying to get a draft of a paper done, so.
Okay. Anything else? That's good. Okay, well then we'll see you all next week for an afternoon meeting. Right here.
Have a good week. Ciao, guys.
Thanks, guys.
Bye.
Have a good visit.